We have learned a lot about linear regression, especially the home prices example. Linear regression can be used to predict other things such as weather and stock prices. And in all these examples, the prediction value is continuous. There are other type of problems such as predicting whether email is spam or not, whether the customer will buy the life insurance product or person is gonna vote for which party. All these problems, if you think about it, the prediction value is categorical because the thing that you are trying to predict is one of the available categories. In the first two example, it is simple yes or no answer. In the third examples, it is one of the available categories. Whereas in case of linear regression, the home prices example, we saw that the predicted value could be any number. It is not one of the defined categories. Okay. Hence, this second type of problems is called classification problem. And logistic regression is a technique that is used to solve these classification problems. Now, in the classification examples that we saw, there are two types. So the first example was predicting whether customer will buy insurance or not. Here the outcome is simple yes or no. This is called binary classification. On the other hand, when you have more than two categories, that example is called multi-class classification. Let's say you are working as a data scientist in a life insurance company and your boss gives you a task of predicting how likely a potential customer is to buy your insurance product. And what you are seeing here is the available data, and based on the age, the information you have is whether customer bought the insurance or not. Now here you can see some patterns such as young people don't buy the insurance too much. You can see like there are persons with 22, 25, these kind of ages where 0 means they didn't buy the insurance. Whereas as the person's age increases, he's more likely to buy the insurance. So you know the relationship, and you want to build a machine learning model that can do a prediction based on the age of a potential customer. So as a data scientist, now this is the job you have been given. Now the first thing you would do when you have this data is you will plot a scatter plot which looks like this. When you have worked on linear regression problems already, the first temptation you have in your mind is you start using linear regression. So when you draw a linear equation line using the linear regression, it will look something like this. Now, how did we come up with this line? For that, you can follow my previous linear regression tutorials. If you think about it, what I can do here is I can predict the value using linear equation line and say that if my predicted value is more than 0.5, so here this is 0.5. If it is more than 0.5, then I will say, okay, customer is likely to buy the insurance. If it is less than that, then he is not going to buy the insurance. So anything on the right hand side is yes, anything on the left hand side is no. Now of course we have these outliers, but we don't care about them too much because for 90% of the cases our linear regression will work okay. Now imagine you have a data point which is far on the right hand side here. So say a customer whose age is more than 80 years, let's say he bought your insurance, okay? Then your scatter plot will look like this and your linear equation might look like this. In this case, what will happen is when I draw a separation between the two sections using 0.5 value, here the problem arises with these data points. Actually, the answer was yes here, but my equation predicted them to be no. So you can see that this is pretty bad when you use linear regression for data class like this. Now here is the most interesting part. Imagine you can draw a line like this. This is much better fit compared to the previous linear equation that we had. Okay, and here when you draw a separation between using 0.5 value, you can clearly say that this model works much better than the previous one. The question arises, what is this line exactly and how do you come up with this, right? If you have learned statistics, you might have heard about sigmoid or logit function, and that's what this is. Okay, now the moment you hear this term sigmoid, you might pause this video and start googling about sigmoid, and it is fine. You can read all the articles about sigmoid or logit function to get your understanding correct on mathematics behind it. But if you don't want to do it, I will give you a basic idea. The sigmoid function's equation is 1 divided by 1 plus e raised to minus z, where e is some mathematical constant. It's called Euler's numbers. The value is this. Now think about this equation for a moment. What we are doing here is we are dividing by 1 by a number which is slightly greater than 1. And when you have this situation, the outcome will be less than 1, correct? So all we are doing with this sigmoid function is coming up with a range which is between 0 to 1. So if you feed set of numbers to this sigmoid functions, all it will do is convert them to 0 to 1 range, and the equation that you will get looks like S shape, right? So if you plot a 2D chart, it will look like S-shaped function that we saw in the previous slide. Essentially, what we are doing with logistic regression is we have a line like this, which is linear equation, and you know the equation for our linear line, which is mx plus b. All you're doing is you are feeding this line into a sigmoid function, and when you do that, you convert this line into this S shape. Okay, so here you can see that my z I replaced with mx plus b. So I applied sigmoid function on top of my linear equation, and that's how I got my S-shaped line here. All right, now all of this math is just for your understanding. As a next step, we are going to write logistic regression using sklearn library, and these details are abstracted for you, so don't worry about it. You don't have to implement all of this mathematics. You will just make one simple call and it will work magically for you. All right, so let's get straight into writing the code. Here is the CSV file containing the insurance data. You can see there are two columns, age and whether that person bought the insurance or not. And we are going to import this into our pandas data frame. So I have loaded my Jupyter notebook by running Jupyter notebook command on my command line. I imported a couple of important libraries, and then I imported the same CSV file into my data frame, which looks like this. And now I'm going to plot a scatter plot just to see the data distribution. And you can see that I get a plot like this. Here, these are the customers who didn't buy the insurance. These are the ones who bought the insurance. And you can see that if the person is younger, he is less likely to buy the insurance. And as the person gets older, he is more likely to buy the insurance. The first thing now we are going to do is use train test split method to split our data set. So if you look at our data, we have 27 rows. So we are going to split these rows into training set and test set. Again, I have a separate tutorial for how to do train and test split, so you can watch that. It is basically from sklearn model selection, you import train test split method. Here my x is df age. Now I'm doing two brackets because the first parameter is x, which has to be multi-dimensional array. So I'm just trying to derive a data frame here, and bought insurance is y, and I will say what is my test size. If you want to see the arguments, you can do shift tab and it will show you a help for this function. So I use this a lot, it is pretty useful. So let's see. So there is this taste underscore size parameter. So let's use taste underscore size. We are going to do, or let's say train size, right? So training size is 0.9, so 90% of the example we are using for training, and 10% we will use for actually testing our model. Now what do you get back as a result? So these are the things you get back as a result. So I'm just going to copy from here, and that's it. Hit Control Enter to run it. Okay, so here there's some warning, maybe they are asking us to use test size, doesn't matter. Okay, let's look at our test. So our test is 18, 23 and 40. So these are the three values we are going to perform our test on. When you look at our X train, these are the data samples we will use to train our model. Right, so let's now import logistic regression. So from same linear model you can import logistic regression. sklearn. All right, so we will have logistic regression class imported, and we are going to create an object of this class. We'll call it a model, and that model now will do a training. Remember, in sklearn, whenever you are using this method fit, you are actually doing your training for your model. So X train and Y train, this is what you use for your training. When you execute this means your model is trained now, and it is ready to make predictions. So for these three values we are making a prediction. So I will do model dot predict and X taste. So here what it is saying is 0, 0, 1, which means first two samples, it is saying these two customers are not going to buy your insurance. And you can see that it's kind of working because they have age of 18 and 23-year-old, and we saw that as the ages, the younger age people do not buy the insurance, whereas I think anything more than 27, 28 they buy. So here the age is 40, so the answer was 1. Okay, if you want to look at the score is nothing but it is showing the accuracy of your model, right? So what you're doing is you're giving X test and Y test, and here the score is 1, which means our model is perfect. Now this is happening because our data size is smaller, we have only 27 samples. But if you have more wider samples, then it will make mistakes in at least few samples, so your score will be less than 1, right? Because of the small size of our data set, the score is pretty high here. Another method to try is, you can see that when you hit, by the way, tab, it will show you all the possible functions that start with predi. Okay, so here you can also predict a probability. So when you predict a probability of X test, it will show you a probability of your data sample being in one class versus the other. The first class here is if customer will not buy the insurance. So for the age 18 and 23, you can see there is 0.6% probability that they will not buy the insurance. Whereas for the person with age 40, it is reverse. There is 0.6% probability that he will buy the insurance and 0.39% probability that he will not 0.39%, really it's really 39% that he will not buy the insurance. If you want to do one off, then you can just do model.predict 56 he will buy the insurance, that's why you had 1, and if you had something like 25 he will not buy the insurance, that's why you get 0. So this model that we built is working like pretty well with logistic regression. That's all I had, and now is the time for exercise. So if you know about Kaggle website, this is the website that hosts different coding competitions, and it has one of the more important feature, which is the datasets. So if you go to this dataset section, you can download various datasets based on the type, based on the file type, or you can even search for datasets. So if you want to do some Titanic data analysis, you can search for that. Basically, you can just explore these datasets for exercises. From this, I have downloaded this HR analytics dataset, where there is an analysis on the employee retention rate or employee attrition rate. If I open that CSV file here, it looks like this, where based on the satisfaction level, based on number of projects or average monthly hours that person has worked on, you are trying to establish correlation between those factors and whether person would leave the firm or whether he would continue with the firm. These kind of analytics are very important for HR department because they want to retain the employees. And if you can build a machine learning model for HR department, then they can focus on specific areas so that employees don't leave the firm. So that's what you're going to do. You are a data scientist. You're going to work for your HR department and give them a couple of things. So I have mentioned all of those things in the Jupyter notebook, which I have available in the video description below. So if you open that notebook, you will see all the code that we just went through in this tutorial, and at the end you will find this exercise section. Okay, so there is a link here. You download the dataset. If you don't want to download it, the same level as this notebook, there is an exercise folder. So download the CSV from that, and you're going to give answer on these 5 questions. Okay, first one is, out of all these parameters that we have, you want to find out which factors affect the employee retention by doing some exploratory data analysis. You will also plot bar charts showing the impact of employees' salaries on retention. Also plot the bar chart showing the impact of department and employee retention. And then using the factors that you figured in step 1, you will build a logistic regression model. And using the model, you are going to do some prediction. In the end, you will measure the accuracy of the model. Let's do that exercise. In the comments below, let me know your answers. And if you want to verify the answers, then I have a separate notebook at the same level in exercise folder, which has all the answers. But don't look at the answers directly, okay? A good student is